So now that we know how to draw vectors and we can identify the magnitude and direction, now we want to write the vector into its components. Components are just the parts. They're just the x and y components or parts of the vector. So we're going to identify these things called a unit vector. So unit vector going in the horizontal direction would be 1 unit long, and I'll label that as 1 unit. And we're going to call a vector going in this direction I. Now I is written just like the imaginary number. It's not an imaginary number, so somehow I have to tell you that it's not. So we're going to use the symbol hat. It's kind of like this upside down V. A vertical component is just that. That is 1 unit in the vertical. And so what I want to do here is I'm going to call that vector J. And again, we put a hat on it. And so we write it as the vector is going to look like something I hat plus something J hat. And that just tells me the vertical and horizontal components or how much I'm going to use to draw that vector. We're also going to label it like this. Just another way to illustrate a vector. So this would be your horizontal component for I and your vertical component. So for example, if I had a person walking 3 units east, so I'm just going to label that 3, and 4 units north, I could write that in components, and I could write it 2 different ways. 3, 4, and notice it's not an ordered pair XY. It's very similar, but it's different because of the way we label it, and that signifies to me that I have a vector. Another way we could have labeled it is 3I plus 4J. Now I'm going to put the little hat on there so we know that that's not an imaginary number taking us into the complex. So what we want to do is be able to take a vector that's drawn in some coordinate system and write it in its component form. So essentially, if you go back and think about what we did in the last lecture, we're going to make this darn right triangle out of it. So we're going to call this horizontal piece down here not X anymore. We're going to call it I hat, and this is J hat. And I know that this length over here, the hypotenuse, is the magnitude of the vector, and I know that this is theta. So those are the pieces that we were defining earlier. So what I'm going to try to do is find this I hat. I'm looking for the horizontal component. So what I need to know is the direction, theta, and the magnitude, and I can find it. So thinking about SOHCAHTOA, and what we kind of discovered that this was the, let's see, sine was the y component, cosine was the x. Let's see if that has any relationship here. So if I'm looking at theta, I see that the cosine of theta is vector I divided by the magnitude of the vector. So if I'm looking for I hat, that's going to be the magnitude of my vector times the cosine of theta. Likewise, if I'm trying to find J, so I'm looking for J, I can see using SOHCAHTOA that the sine of theta, let's see, sine opposite, vector J, opposite over the hypotenuse, which is the magnitude of vector V. So J hat then is going to be equal to magnitude of my vector times the sine of theta. So we're going to use those 2 component pieces to write it all together. So if I go ahead and take a look at a picture, a vector with magnitude of 3 in the direction of 120 degrees. So let's get a picture of that. So for our purposes in this class, we are going off the x-axis. So 120 degrees is this angle right here. And the length of this vector is 3. That's its magnitude. So my I, which is going to be this direction, this component going in this direction, is going to be equal to, from what we did up here, the magnitude of my vector, which is 3. That would be this hypotenuse out here, times the cosine, remember it's the x, cosine of theta. So in this case, it's going to be the cosine of 120 degrees. My j vector, this is j, okay, that component is going to be equal to the magnitude of my vector times the sine of theta. So in this case, it would be 3 sine of 120 degrees. So we really have no idea how long that is until we take a calculator. And let's go ahead and look. And if I take 3 times the cosine, again, I'm checking to make sure my calculator is in degrees, it says that that's negative 1.5. So I is equal to negative 1.5. That's its component horizontally. My vertical component is 3 sine of 120 degrees. And that is about 2.5. So j, again, I better put hats on this so we know what I'm talking about. I'm just going to round that to 2.6. So if I want to put it into component form, negative 1.5i, put a little hat on it, plus 2.6j, or negative 1.5 comma 2.6. Now let's see if that is reasonable. Negative 1.5, it looks like I went to the left. I went up 2.6. I can see it's shorter than 3, so I know that it seems fairly reasonable. So again, we're just going back to this right triangle trig and defining them in terms of our trigonometry so that we can find the length of the horizontal or I component and the vertical j component. Let's try another one. So we have a vector formed by 2 points. The first one is negative 1, 3. And the second point is 2, 5. So here's my vector. I want to write it in component form, so we're going to write it 2 ways. I don't think I need trig here because I can just count how far over I went and how far up I went. So I think I can find my I component just by counting. It looks like I went 3 horizontal, and I went up 2 vertical. So if I want to put it into component form, 3 comma 2, make sure you use that to say that you're in vector form. Or I could write it as this vector is 3i, put a little hat on it, plus 2j, put a little hat on it. So it's a way that we can write vectors mathematically and not just give the magnitude and the direction. We can actually describe where they're at in terms of somewhat like a coordinate plane system with an x and a y. We change it to I and j.